So this question here is question number 4 from exercise 1 of alcohols phenol ethers of phase 5 book. So when we take the question here, the question is about conversion again. Now the conversion is, the first one is convert 3-phenyl but 1-ene to 2-phenyl butan to all. So that is our question. So let's write the reactant first. The reactant is but-1-ene. So I'm writing the buta chain, which is 4-carbon chain. First carbon has a double bond. So write the double bond there. And then on the third carbon is a phenyl ring. So instead of making it very clumsy and just taking it as C6H5, you can write a benzene ring also. Now fill it up with hydrogen. So CH3, CH, CH, CH2. This is your reactant. Now you have to convert it into butan to all, 2-phenyl butan to all. So you are going to subject this to what? You can subject this to acid catalyzed hydration. So when we subject this to acid catalyzed hydration, which is an electrophilic addition reaction. So what is happening here? To start the acid catalyzed hydration by electrophilic addition. This will be an electrophilic addition which follows which rule? Markovnikov's addition reaction, or Markovnikov's rule it should follow. So Markovnikov's rule results in, or it is based on what? It is based on the fact that the intermediate generated is most stable intermediate. So H plus will attack in such a way that it will give the most stable carbocation. So it has to attack on the carbon, first carbon, to generate the secondary carbon carbocation. So I will write the secondary carbocation here. We are taking it. So CH plus CH2. Now CH2 converts to CH3. Now this hydrogen H plus here can attack on the other carbon also, but in that case it results in primary carbocation. So adjacent one is an secondary carbocation, so that is preferred. Now this was what? Secondary carbocation. But if you observe the carbocation, the adjacent carbon to it, that is what, which one is present here? This one here is benzylic carbon first of all, and it is a benzylic tertiary carbon. So immediately this carbocation will rearrange, and by what? By 1, 2 hydride shift. It will undergo 1, 2 hydride shift. So that what will happen? The hydrogen from this carbon transfers to this carbon. So that what will we get? We will get a tertiary carbocation, which is preferably a benzylic position. So CH3, C plus C6H5, CH2, CH3. Now hydration can easily happen. So what are we going to get? This will be hydrolyzed now. So that what is our product? Our product is what we expected. 2-phenyl to butanol. 2-phenyl. So this is the second carbon which has a phenyl ring also, which has a OH group also. So this is how the conversion is happening. So what did we do? We have subjected it to acid catalyzed hydration so that we'll get first secondary carbocation. Then the secondary carbocation undergoes 1, 2 hydride shift, which results in a benzylic, tertiary benzyl carbocation. Why is the shift happening? Because it results in a much better intermediate. Stronger the intermediate or a stable the intermediate, stable is the product obtained. That's why the hydride shift happens, resulting in tertiary benzyl carbocation. As a result, the product obtained is 2-phenyl butan to all. So that is about the first conversion. Now let's come to the next conversion. Now the second conversion what we have here is we have an alkene and we are preparing what? Cyclopentyl methanol has to be prepared. So I am taking a cyclic ene here, which is given, and we are just subjecting it to hydroboration oxidation. So we are trying to make it react with diborane. So as a result, what should be formed? When diborane is participating, the rule it follows will be what? Anti-Markovnikov's rule. Because the product is methanol, so obviously you have to make a conclusion about what reagent you should use. Based on the product cost, select the reagent. So here it has to follow anti-Markovnikov's rule. So that what will happen? There will be a corresponding CH2 and we will get a trialkyl borane. Now this trialkyl borane can be subjected to oxidation. So that what is formed? There will be formation of the respective cyclopentyl methanol. Cyclopentyl, and there is a CH2 group. There, the OH group is generated. So this is cyclopentyl methanol, because on the methanolic carbon OH group is present. So that is our product. So what did we do? Since we need an primary alcohol here, we are preparing a primary alcohol here. So I wanted something which is following other than Markovnikov's rule, that is anti-Markovnikov's rule. So the best reagent we can employ is hydroboration oxidation method, so that we get our product. Thank you.